One of the first things I bumped into when I started writing Zig was release modes. At first I thought, do I really need 4 different ways to compile my code? But as I dug in, I realized that release modes are one of Zig's most practical features. They let you explicitly choose between safety, speed, and binary size, depending on whether you're prototyping, testing, shipping, or really just whichever one you want to choose. So today I'm going to walk you through each release mode in some detail, show how they differ, and then benchmark a simple Zig program across each of the release modes. Okay, so what are release modes? Whenever you build a Zig program, you tell the compiler what trade-offs you're willing to make. Some languages hide these decisions behind like a generic debug or release switch, but Zig, like most things, makes them explicit. In the case of using like Zig build exe, which is what we'll use for this tutorial, you can use the -o flag, as in like -o for output, like this. And you'll be able to run something like Zig build exe main.zig. In our case, it'll be source main.zig -o debug. If I could type debug properly, like that. So yeah, you get the idea. There are 4 different release modes. There's debug, ReleaseSafe, ReleaseFast, and ReleaseSmall. If you don't specify one, debug is what you're getting. It's the default. So let's talk a little bit about the code that we're going to run through. It's a bit contrived, but I think it should hopefully convey the point fairly well. So I've got a Fibonacci sequence. We're calculating Fibonacci sequence of 44. We're doing some new Zig 0.15.1 stuff. Well, worth mentioning, this video, the code has been tested on 0.15.1. It will not work on anything before that. It may or may not work on anything after that. We tend to have breaking changes pretty frequently in the Zig community. So just keep in mind that some of this may change depending on when you watch this video. Okay, so we're essentially getting a standard out handle to write to. We have the start time that we're capturing. We calculate the Fibonacci sequence of 44. That it's big, but not too big. And then we're printing Fibonacci 44, and then we're printing the result. And then we calculate the duration, and we print out the duration. So this is cool. This is good. But there's also a tool called Hyperfine, which is a CLI benchmarking tool with a ton of flexibility, and it's just really nice. So we'll also be using Hyperfine to benchmark this, and we can compare the Hyperfine results with the internal program duration results as well. So we'll get into that in just a second. But I also want to show you this poor man's Zig build shell script. So this is what we're going to be running. This will run everything for us. So we have Zig build exe, source main, optimize for ReleaseFast, and then the output name will be main ReleaseFast. So we're doing the same thing here for ReleaseSafe, ReleaseSmall, debug, and then we're going to run Hyperfine. So Hyperfine takes in a program. In our case, it'll take in the programs that we've just compiled. We're going to run that program 5 times. And we're also going to use a warm-up of 3. So this will actually run 8 times. The first 3 times are just warm-ups and will not factor into the average. This is generally something you tend to do with like things where you need like memory warmed up or IO handles kind of ready to go. It's just a pattern that I've tended to embrace. So the warm-ups here might not be too useful, but I tend to do them just about any time I end up using Hyperfine, unless it explicitly makes sense not to. Okay, so yeah, we'll run Hyperfine, and it'll run that for us. So I'm going to go ahead and kick this off, and while this is running, we're going to talk about the different build modes. So we're going to start with debug mode, since that's what Zig gives you out of the box. Debug mode is essentially Zig's safety net. You get full safety checks like bounds checking, integer overflow detection, invalid pointer usage checks. You get your debug symbol, so if you happen to have a stack trace that you run into, it'll hopefully be easy to follow or easier to follow. And you get compatibility with debuggers, which is extra nice. You also get no optimization, so your programs are going to run slower and the binaries are going to be larger because the compiler's not optimizing anything for you. ReleaseSafe is like debug mode's older sibling. It still cares about safety, but also wants to show how your program performs with optimizations. So you do get some optimizations. Execution will generally be faster than debug. You get some runtime safety checks. Those still remain. So you get bounds, overflow, and null checks. All of that stuff still active. And unfortunately, you get large binary sizes. So you pay for the safety and optimizations in terms of your binary sizes. It's not going to be as big as debug because you don't have those debug symbols. But yeah, something to be aware of. It's kind of like an in-between, like a mix of all of the other options. So smaller than debug, faster than debug, and then as safe as debug. Okay, so then the next one we have is ReleaseFast. This is going to be the pedal to the metal mode. So all of your major optimizations like inlining, vectorization, loop unrolling, the works. You get no runtime checks. If you index out of bounds, you are on your own. Zig is not here to catch you if you fall. However, the trade-off is that you get that maximum performance. The compiler is going to optimize the heck out of things, and it assumes that you know what you're doing, which also could be a double-edged sword. If you are building like a game loop or a high-performance tool, ReleaseFast makes a noticeable difference. But, and this is important, bugs that safety checks would catch are now yours to debug the hard way. I see that this is finished. We'll get into this in just a second. Don't look too far ahead, but we have one more to talk about, which is ReleaseSmall. So ReleaseSmall is taking a different tack. It's going to optimize for binary size, and the code size is minimized, which is ideal for embedded systems, WASM, or environments with really strict limits. Your performance may vary. Smaller doesn't always mean faster, but in some cases it can be as well. Some of the optimizations that you would normally get from like ReleaseFast, for example, are sacrificed to shrink the binary. This is really useful for distribution. So this is great if you're writing like embedded systems type things, or you really just want small programs. I personally have a really strong opinion that CLI programs shouldn't be several megabytes or more. And this would help me make sure that, you know, the Zig project that I'm building is nice and tiny. So I've also used ReleaseSmall for experimenting with WebAssembly for a while, and the resulting WASM that you get is generally quite a bit smaller compared to ReleaseFast. Okay, so we talked about our benchmarks. We talked about Hyperfine. We have some output here. So our first benchmark runs ReleaseFast, and it takes about 2.1 seconds. So keep in mind that this is the average over 5 runs, so the mean over 5 runs here. And then our delta? That might not be the correct term. Sorry, math was never my strong suit, and all of the math symbols have more or less been erased from my memory. ReleaseSafe is going to give us about 3 seconds. ReleaseSmall took about 2.1. This is interesting that ReleaseSmall and ReleaseFast are about the same, and technically, ReleaseSmall is even faster, just ever so slightly. And again, this could change with more runs too, so just something to be aware of. And then we have our debug, which comes in at a slow in quotes, 4.4 seconds, which, you know, still pretty fast, all things considered, but much slower than the other options. Okay, and then if you haven't used Hyperfine before, you can also see the user time and the system time. So just something to be aware of. The system time for ReleaseSmall and ReleaseFast, both absolutely minuscule. Actually, for all of these, it's really, really tiny, but just something to be aware of too. So how do these hold up, just out of curiosity, against the actual internal benchmarking? So all of the programs do some duration-based benchmarking. We can see that it takes, what, Yeah, 2.1 seconds for ReleaseFast, which is 2.1 seconds. So yeah, pretty accurate between the internal benchmarking and Hyperfine. Hyperfine just gives us a little bit more to work with and multiple runs and averages, and it's a really excellent tool. Okay, so this kind of paints a couple of these in a bad light, right? We talked about debug and how you get debug symbols. That is so powerful, especially when you're building or debugging something, and it works with a debugger quite well. So like the benefit of debug makes sense, small makes sense, fast hopefully makes sense, safe hopefully makes sense at this point too. So some of those safety checks without the debug symbols. Somehow, again, ReleaseSmall ends up being faster than ReleaseFast in this one specific case. But I want to also take a look at the file size of these, because I feel like that's important too, especially with one of them being intended for small size programs. So what I want to do is, let's do like an ls-l, maybe awk, print f. We want a digit. We'll do another digit. We'll put KB at the end of that one. And then string, I guess, new line. And then, do I remember the indexing for ls? I feel like no, I don't. Okay. 1, 2, 3, 4, 5. Okay, so 5 would be file size, which means 6, 7, 8, 9. Okay, 9 is the file name. Let's try this again. So let's grab this, and if I press the right keys, paste this here, we want 5. We want 5 divided by 1024, and then we want 9. And then we need to close our string, and then let's just grep for main. Holy cow, that actually worked. Okay, great. So looking at the file size here, we can see a couple different things. Notably, ReleaseSmall is the smallest at about 51 kilobytes. Next would be ReleaseFast at about 68 kilobytes. And then 5 times as big as ReleaseSmall, we have ReleaseSafe here with those safety checks that we've talked about. And then about 4 times as big as ReleaseSafe, we have the debug with our debug symbols and all of the safety checks that we would have as well. So just looking at the file size, just to kind of get an idea of what these different optimizations do, you can see, like I said, ReleaseSmall is tiny, ReleaseDebug is the Goliath by comparison, but it has useful information and those safety check features. So here's my advice on choosing between them. So for debug, you're going to use this for everyday hacking, prototyping, and honestly, you could stay in debug mode for a very, very long time, depending on what you're doing. ReleaseSafe is going to remove some of those debug symbols. So if you do care about, speed to an extent, but you still want those safety checks, and maybe you don't need the debug symbols, ReleaseSafe is going to be a pretty good option there. ReleaseFast, that's going to be where your performance matters, so quantitative trading or game loops or things of that nature. And then ReleaseSmall is going to be where size matters. So if you are looking for deploying to, I don't actually have them on my desk. They're in my tackle box over here, but I've got some Raspberry Pi Picos that I'm doing some microzig stuff in my spare time, and ReleaseSmall can be useful there because file size matters, and we need to keep things as tiny as possible. Okay, so the release modes are not just compiler quirks. They're a clear, explicit way to align your build with your goals. So whether you want safety, speed, or size, Zig hands you the dial. My advice, start in debug, switch to release when you're ready to stabilize things, and then pick between fast or small depending on your production needs. Or just stay with ReleaseSafe or debug. If you want a deeper dive, check out the official Zig docs on the build system. And besides that, if you found this video helpful, I would appreciate it if you gave me a thumbs up on the video. It helps me. I'd like to think that helps you, and we have a nice symbiotic relationship together. If you haven't yet, subscribe to the channel because, what? What are you doing? Come on, subscribe. And we're all friends here. And if you'd like to be a part of that friendly community, you can also join the Discord, which there is a link in the description. I think that's it, so thank you very much, and have a great day.